Hello everyone, welcome back to ML and AI from scratch. I am glad you are here for episode 2. In the last episode, we established what machine learning actually is, teaching computers using examples, not the rules. But that is machine learning. If you haven't watched that one, go back and start there because this episode builds directly on it. Today, we are going one level deeper. Machine learning is not a single thing, it's a family of approaches, and there are three distinct types, each of which learns in a completely different way. By the end of this episode, you will know exactly what those three types are, how each one works, when to use each one, and how to choose between them when facing a real problem. Let's get into it. Four things today. The three types of ML: supervised, unsupervised, and reinforcement learning, and how each type learns, and the real world examples of each type, and a simple framework for choosing the right one. Think of machine learning as having three families, and each family has a fundamentally different way of learning. The first one is supervised learning. It learns from labeled examples. Someone has already done the work of taking the data with correct answers. The second is unsupervised learning. It gets raw data with no labels and it has to figure out the structure on its own way. The third one is reinforcement learning. There's no data at all in the traditional sense. Instead, there's an agent, an environment, and a reward signal. The agent learns by trying things and seeing what works. These three types, three completely different philosophies. Let's take them one at one time. Supervised learning. Supervised learning is by far the most common type you will encounter, and it will be the focus of most of this course. The core idea: the model is trained on labeled data. Every input already has a correct answer attached to it. Here's the analogy I like. Think of a student learning with a textbook that already has the answer key. The student sees the thousands of problems, each paired with its correct solution. Over time, they learn the pattern not by memorizing the answers, but by generalizing from them. That's exactly what the supervised learning models does. Look at the flow on the right of this site. You start with the label data, you train the model on it, then you feed in a new input the model has never seen, and it produces a prediction based on everything it learned. Now, let's look at real world examples. Email spam detection. Trained on millions of emails already tagged spam or not spam. The image recognition is the next example. This is trained on millions of photos already labeled whether it is a cat, dog, or car. And the third one is house prediction, house price prediction. Trained on the thousands of past sales, each with the known final price and the square feet of that house. And the final last one example is fraud detection. It is trained on transaction already flagged as fraudulent or legitimate. In every case, the pattern is the same. You have labeled data, you train, and the model learns to predict labels for new data it hasn't seen before. Supervised learning splits into two main categories: classification. It is predicting a category like spam or not spam, cat or dog, and the regression. It is predicting the number like a house price or a stock value. We'll cover both in depth later in this course. The next one is unsupervised learning. Unsupervised learning is where things get more interesting and more philosophically different. Here you give the model data with no labels at all, no correct answer, no pre-tagged categories. The model's job is to discover the structure in the data entirely on its own way. My favorite analogy: Imagine you are handed a jar of foreign coins from a country you have never visited. No guidebook, no labels. But you start sorting them, naturally grouping similar sizes together, similar shapes, similar colors. You have created categories without anyone telling you what those categories should be. Look at visualization on this right side. Three groups of dots, each cluster naturally separated, no labels, just structure that emerge from the data. This is used when you either can't label your data or you don't know in advance what the categories should be. Now let's look at these examples. Customer segmentation. It's an initial example. A company has millions of customers and wants to understand distinct behavioral groups without knowing in advance how many groups there are or what defines them. And the second one is the topic modeling. Feeding thousands of news articles on into a model, having it surface the major themes automatically. And the third one is anomaly detection. The model learns what normal looks like and what's the anomaly looks like and flex anything that deviates. And the final one is the recommendation engine. The most common unsupervised technique you will use in this course is clustering, specifically K means. We will build it from scratch in module 2. Reinforcement learning is the most different of three and arguably the most fascinating. There's no dataset, no labels. Instead, there's an agent that interacts with an environment and receives reward based on its actions. The goal: learn a policy that maximizes cumulative reward over time. The best analogy is learning to ride a bike. Nobody hands you a manual, nobody labels your movements as correct or incorrect in real time. You just try, you fall, you adjust. After hundreds of small attempts, the correct movements becomes instinctive. Look at the diagrams. The loop goes: agent takes an action, environment responds, reward signals come back, agent updates its policy, and repeat. This loop runs millions of times in training. Let's look at the real world examples. AlphaGo, DeepMind's system that learn to play Go at a superhuman level, not by studying human games, but by playing millions of games against in itself. And the robotics. A robotics learning to grasp objects through trial and error with a positive reward every time it succeeds and the negative reward every time it fails. And the third one is edge beating system, an agent that learns which edge to show in which context to maximize click through rate. And the final one is self-driving cars. I want to be honest with you, reinforcement learning is advanced. We will touch on the concept in this course phase 5 of this material. For now, the key thing to understand is the paradigm. Reward driving, trial and error learning is the reinforcement learning. Pull all three side by side so the difference really land. Along the top, supervised, unsupervised, reinforcement, three columns are there. The data type: supervised needs label data, unsupervised need unlabeled data, reinforcement learning needs a reward signal, not data in traditional sense. The techniques: supervised uses classification and regression, unsupervised uses clustering and dimensional reduction, and the reinforcement uses policy learning and optimization. Let's look at the examples. For the supervised learning, spam filters and image recognition. For customer segmentation and anomaly detection for unsupervised, and the game AI and robotics for reinforcement learning. And the best for is supervised is the most common type in practice. Unsupervised is ideal when labels are unavailable or unknown. Reinforcement is built for sequential decision making problems. Keep these slides in mind. It's a reference you will return to throughout the course. So, when you face a real problem, how do you pick the right type? Start with one question. Do you have label training data? It's a initial question. If you say yes, use supervised learning. You already have the correct answer to learn from. That's the most powerful signal you can have. If the answer is no, is there an environment you can simulate? The second question you have to ask. If yes, reinforcement learning is a candidate. You can let an agent explore and learn from rewards. So the answer is no, use unsupervised learning as your path. You will let the model find structure in raw data itself. Here, one practical note at the bottom of this slide, and I want to be direct about this. In real machine learning practice, especially as a beginner, you will spend 80% of your time in supervised learning. That's where the data sets are, that's where the stabilized tools are, and that's where employers expect competence. This course will reflect that reality. We will build intuition for all three, but we will go deep on supervised. The next episode, episode 3, is the machine learning pipeline. The full end to end journey from raw data to a working prediction. That's a scaffolding everything else hangs on. The episode 4 is environment setup. Python, Jupyter, scikit-learn, hands-on every from the very start. And the episode 5 is your first real model, linear regression with theory and code on a real data set. We have learned three ways of learning. Initial one is supervised. Learn from labels. Unsupervised, find your own paths. Reinforcement, learn from rewards. Most of what you build in this course is supervised learning, and that's not a limitation, it's a focus. Supervised learning powers the majority of real world machine learning systems you will encounter in your career. If this is clicking for you, hit subscribe. Episode 3 is coming next, and it's where the full picture starts to form. Drop any questions in the comments. I will see you in the next one. Thank you all.